Okay, we're nearly at time, so Haripriya, please take it away.
All right. Hello, everyone. Thanks for joining. Today, we'll be going on a deep dive into one of the most interesting and often misunderstood areas in SQL Server, and that is memory-optimized TempDB. This is one of those topics you just don't understand by reading the documentation. I did a lot of digging, testing, and researching to exactly understand how this feature works. This has a lot of nuances to it and some surprises along the way, which I'm very excited to share with you today. About myself, this is Haripriya. I have been working as a SQL Server database administrator for 11 years now, based out of Boston. I work a lot on AWS EC2 instances with SQL Server installed on them, and I'm an AWS certified solutions architect. I actually started speaking with new stars of data last year, and since then, I've been speaking at user groups, SQL Saturdays, and also got an opportunity to speak at PAS Summit in Seattle as part of the New Stars of Data program. And I also found out that I liked to write technical articles, especially about SQL Server. I'd call it probably a newfound interest. So I've been doing, probably good amount of blogging. And for my speaking engagements and the blogging activities that I've been doing, I recently received the MVP award from Microsoft a couple of months ago. So that's about me. And for some reason you happen to watch the session later and if you have questions, feel free to DM me on LinkedIn. And this slide deck and the demo scripts that I would be showing you is available on this GitHub link right here, and also on 8KB that Andrew probably mentioned just a few minutes ago. All right. So what do we usually do when we notice TempDB contention? Well, at least I can tell you what I do when I notice TempDB contention. I just go ahead and add the data files in TempDB and expect the issue to go away, because that's how it has always been, right? So whenever I see an issue with TempDB, all right, let me go add 4 data files and the issue will go away. But this one time, it was very stubborn. The issue would not get resolved. And I'm like, adding 4 data files, 8 data files, why is it not going away at all? I started wondering. And that's when I realized I was missing an important piece where the issue that I was seeing on TempDB is completely different. Though it is on TempDB, it's not the one related to data files, and that's something new. Well, it is not new, but it's new to me. So let's see what that is. All right. So you have page latches on TempDB. So this is called TempDB contention whenever you see too many page latches. All right. So if you see that on PFS, GAM or SGAM pages, then you add data files, you check contention, you add more data files, and you go in that loop. So this box in green is resolved in SQL 2022 engine by default, and we are not interested in this part right now for this session. All right. What we are more interested is this one, the system objects. So when you see page latches on TempDB on system objects, then that is called metadata contention, because the contention on system objects is nothing but metadata. So that's why it's called metadata contention. When you have that, you can either cache the temp tables or avoid dropping the temp tables at the end of the stored procedure. And if you check again for contention, you will see maybe, 30% or 40% of contention is resolved, but most of the contention is still there. That's when you enable this feature that we are going to be discussing, this memory-optimized TempDB feature. All right, so that's what is going to help address this metadata or system objects contention. This is the piece we are interested in today. I brought this flowchart up. That way you know where that data files part exists and where this memory optimized TempDB part exists, and you can see the difference. All right. And personally to me, this session has a lot of, oh, wish someone had told me this moments, a lot of those moments in this session. So I actually structured this session in such a way that, how I would have expected, like, wish someone told me this, and I would have wanted someone to explain it in a way that is clear to me. So I framed this session in that same way. So I really hope this session is helpful to you in the way that it turns out. All right. If you are new to this feature and you have never worked on it, and if you're interested in checking this feature out, you will learn a lot of stuff, and I really hope there's some clarity when you learn about this feature. If you have already worked on this, then I'm sure you will be able to pick up a few nuances which may not have been obvious before. All right. So the agenda for today's session, this session will be about what this feature is all about, when to use it, when to implement it, what's the best workload that you can use this feature for, and importantly, what are the limitations and when not to use this feature. And I will also show you the management techniques. That way you can get the best out of this feature. And this will be an advanced level session where I expect the attendees to know the basics of TempDB. And if you have any questions, feel free to post them in the chat, and I will be making breaks in between the session to answer any of the questions that you may have. So this version, it was released in 2019, so it's available in 19, 22, and 25. You have it on Enterprise and Developer Edition. It's not available on Standard Edition, and it is neither on Azure SQL or managed instances. So what is this feature? It's a very new feature released in 2019. It is part of that in-memory OLTP umbrella, but this in-memory thing is just for TempDB in this feature. So what this does is it moves 12 system objects to memory. And let me tell you what that is. Imagine this is a TempDB drive. You have many objects in that drive, like system objects of TempDB, and temp tables or table variables or any internal work tables that SQL Server creates. Everything is on that TempDB drive. When this feature is enabled, what happens is 12 of those system objects move to memory. And remember, nothing else moves to memory, just those 12 system objects move to memory, and everything else remains in the TempDB drive. All right, so when those 12 system objects move to memory, there will not be any locks. If there are no locks, then that means there's no bottleneck or there's no contention. So that's the concept of this feature. Move those 12 system objects to memory and get rid of the locks and contention. All right. So what are those 12 system objects? Let me zoom in here. So you will see sys rs calls, sys row sets, all those sys objects, only the system objects. All right, these 12 system objects. In 2019, I believe until probably CU2, you'll just have 10 objects, but anywhere after CU2 or 3, you should have all these 12 objects that will be moved to memory when you enable this feature. All right. So what's exactly going on in the background? If you have any create temp table or alter temp table, I'm sure we all have it in our stored procedures and in many places. So whenever there is a create or alter or DDL operation on a temporary object, it needs to insert metadata into the system objects. And to do that, it needs to get a lock onto the system objects. So let's take a look at this stored procedure here. You have a create temp table, and then here there is create index on temp table, which is nothing but alter temp table. So whenever you have create temp table or alter temp table, this is the internal process that actually happens. So when this stored procedure executes, then it will need to insert metadata into the system objects, and for that, it needs to get a lock. Under normal circumstances, when you have a few executions of this stored procedure, Well, these operations, they can easily get a lock onto the system objects and be done with the operations. But on a very busy production server where you have thousands of concurrent executions of stored procedures, what happens? Now, all these operations, they are waiting to get that lock onto the system objects to insert metadata. So as these operations are waiting in line for those latches, it causes contention. And this contention is on the system objects, and that's why it's called metadata contention. Because system objects are nothing but metadata objects. So that's why it's called metadata contention. So now, how do you think the feature is going to help? Because the key concept of this feature is move those system objects to memory, right? So here our problem is all those latches or the locks that it is waiting for. So when you enable the feature, the process is the same. All those transactions, they again have to insert metadata into the system objects. But this time, since the system objects are in memory, they don't need any locks and they can easily do their operations. So there's no lock, that means there is no contention. So that's the idea behind this feature. All right. So the key here is when this feature is enabled, the system objects of TempDB are moved to memory. Then the operations or the stored procedures that have these create alter temp tables in them, they don't have to wait for locks anymore. They will become lock free because they can easily access them in memory. All right. When should we enable this feature? When you have too many stored procedures that are having concurrent executions, like hundreds and thousands of them, they are executing concurrently. And most of the time, many stored procedures do have create temp table or something to do with temporary objects. Those stored procedures, when you have too many of them running concurrently, then this might be a use case. Usually, you will see this on OLTP environments because that's where for every few seconds, there are stored procedures constantly running. And imagine if you just log into the server and check for contention, and if you don't see anything, that doesn't mean that contention doesn't exist. Go check your collections or your monitoring tools, whatever you have. Maybe something happened yesterday. Maybe something happened, the previous night or the week before. Check for any peak hours. If you had that contention, you can go check that out and then go tell your team and sound amazing, right? Just like me. Well, okay, I think we can ignore that part. Anyways, so, you can check your collections and monitoring tools to see if there is contention. Okay, so when you go check now, what are you exactly looking for? So I have made that easier here. So you can get the script actually from the demo or GitHub, but this is how the result set will look like, which I will also show you on the demo. See this, when you run this contention script, you will see wait type page latches, wait resource on TempDB database ID 2. 2 is always for TempDB on any SQL Server instance. And let's ignore these numbers because it's already decoded here for us what the object is. In this case, it is sysidx stats. So whenever you have page latches on TempDB on any of these 12 system objects, then this feature can help you get rid of these page latches. All right. So this is called metadata contention, and this is exactly what this feature will address. Instead of page latch, if you have page IO latch or any other wait type, this feature is not going to help you out. They are all completely different wait types than this one. All right. And it is always TempDB database ID 2. If you see any other database IDs here, then again, this feature is not helpful. All right. So I'm just making it very clear that these are the 3 conditions. It has to be page latch on TempDB on one of these 12 system objects. Then you can enable this feature and it will help you out. All right. So how to enable this? Well, It comes disabled by default because you get to decide, do you need this feature or not? Do you have this contention or no? If you don't have it, you can just ignore it, right? But if you really know that you need this feature and if it's going to help you out, this is how you enable it. Alter server configuration code and turn on this metadata on. After you do this, this needs a restart of the SQL service because there are hackathon DLLs that need to get configured. Hackathon is the code word for in-memory OLTP. All right. Sorry about that. I'll just mute this. Probably I forgot to mute my phone. All right, back to this. So this is how you enable this feature. And then which queries are exactly utilizing this feature? Any DDL operation on temporary objects, like create temp table or alter temp table, global temp table, or table variables. Any DDL operation that you do on these temporary objects, they need to insert metadata into those system objects. So that's when this feature will be utilized. When you do insert into temp table or delete from temp table, then this feature is not utilized for that. Only for DDL operation on temporary objects. Note, not whole of TempDB is in memory. So, just remember that just because it's called memory-optimized TempDB metadata, it's important that you understand that it's just those 12 system objects are in memory. Everything else still remains in the TempDB drive. All right, the temp tables that you create or the work tables that SQL Server creates, everything is in the TempDB drive. Only those 12 system objects are in memory. The reason I'm repeating this is because, I don't want to have any confusion for you at the end, like, oh, memory-optimized TempDB. Does this mean whole TempDB is in memory? No. Just those 12 system objects are in memory. Your TempDB drive is still there and objects are still there on that drive. So the benefits of this feature, of course, when it's moved to memory, there are no latches, which means there are no logs. And because of that, you get very less contention, or most of the times, no contention at all. And that means you get better performance. All right. Any questions?
We do have a couple of questions. So
Okay.
Let's see. Suppose if we move the TempDB to SSD, will this improve performance?
When we talk about metadata contention, no, it's not going to improve the performance. Strictly to metadata contention, only when the objects are moved to system objects are moved to memory, that's going to help with contention.
Okay, and referencing the last couple of slides, do you need a recent compatibility level on your user databases to utilize this feature?
So this has nothing to do with the compatibility level of the user databases, because this is all about TempDB, and TempDB takes the compatibility level from the database engine. So it has nothing to do with the user database compatibility level.
And then finally, I think that you probably answered, but
Okay.
just how do you know when there's metadata contention in like 10 seconds or
Yes.
less, if you want to highlight that again?
Okay, yeah, so when you have page latches on TempDB on any of those 12 system objects, that's exactly, when you have metadata contention. If you want, I can quickly go back to this thing here. So where was that? Yeah, I think this is the one we saw. I have to switch this again. Give me a second. So when you have contention, when you have page latches on TempDB database ID 2 on any of the 12 system objects, then it is metadata contention, and that's when you will enable this feature.
Okay, we've had a few more pop in since
Sure.
you started answering. So once you turn this feature on, are you able to turn it off later?
Yes, of course, yes. But turning on or off for this feature requires a restart, which I will be also doing in the demo.
Okay. And then do we know memory-optimized system tables to avoid using locks?
Do we know memory-optimized system tables are what? Yes. So these system tables of TempDB, when they are in memory, the operations, they don't need to acquire locks to access these system objects in memory. So yes, we are avoiding the locks, and that's what is helping us with contention.
Okay, I'll ask this last one and then I'll let you get back to presenting again. Is there any option for this issue in SQL 2017?
This is not available in SQL 2017. This is available only from SQL 2019.
Okay, I will, well, what's the suggested memory that needs to be added for this feature? And then we'll let you go.
Yes, so the memory actually, you have max server memory and everything, but suggested memory, I'm going to go ahead in this, in the slide, and we'll explain that clearly instead of for a few seconds right now.
Okay.
Anything else?
I think you're good.
Okay. All right, you're good. I will go ahead. All right, where were we? Memory. All right. Let's take a look at, I have to switch this again. All right, so memory part of this feature is very important. So, I really want to make sure you all get this. This has a lot of nuances in it, as I keep explaining. Probably for the next 15 minutes, we will be talking a lot about memory. Of course, the name has memory optimized, so we are going to be talking about memory, right? So how much memory do these system objects occupy in TempDB, in memory? So the moment you enable this feature, it usually consumes, those 12 system objects usually consume less than 100 meg. As the processes keep coming in, as they are using or accessing these system objects, the memory keeps building up. The usage, from 100 meg, you could see going to 200, 500, a gig, and more than that. And we have the label here, memory clerk _ XTP. XTP is extreme transaction processing. So to check out the memory that's used by this feature, this is the label we will be checking, memory clerk _ XTP. So where is this stored in memory? It's actually in a separate part. It's not in the buffer pool or cache or anywhere else. It's actually in a separate part where logs are not needed. And because this is TempDB, you don't need any file group configuration because it's all non-durable. Let's talk about resource governor. So let me show you this, that way we can talk more about it. So if you check out the SQL Server instance, resource governor is usually under management, because resource governor is something that you use to manage the resources. It is almost like a traffic control for SQL Server, because you get to choose how much I/O or CPU or memory that you can assign to different workloads. This actually helps you in preventing one workload from taking away all the resources. For example, imagine if you have any reporting queries that's like taking up a lot of resources, by which you are not able to, or the critical transactions are not able to get all those resources. So that's the reason here we can be using resource governor. That way you can stop those reporting queries, or minimize the resources that are given to other queries that use a lot of CPU or memory. Yeah, so this is the best way I can think of, like a traffic control. You get to control how much memory you want to give to that particular query, or how much CPU you want to give to that particular application. All right, that's what the resource governor is for. So to make use of this resource governor, we will create a resource pool. In this case, to limit the memory usage for any workloads that are using this memory-optimized TempDB. Here we will be using a user-defined resource pool. There are also internal resource pools and some system resource pools, but let's not worry about it. We will create a user-defined resource pool with max memory percentage 70. You can give any number that you like, but with the rigorous testing that I have done, I've seen things work better when it is more than 50%, and 70 seemed to be a sweet spot for our systems. All right, and for this to take effect, you run the reconfigure statement on the resource governor. So what does this resource pool mean? So when you have 70 as the max memory percentage, then that means any queries that are coming in that are using this memory optimized TempDB will not take up more than 70% of your server memory. All right, that's what this means. You are restricting the usage, limiting the usage for those workloads. And for this to work, after you create the resource pool, you actually need to bind this resource pool to TempDB. So this is how you do it. Set memory optimized on, and then just mention that resource pool that you just created. And again, for this to take effect, you have to restart the SQL service. All right. So I have done a lot of this on my test servers, on my production servers, and everywhere. So one fine day, I was just testing this out, the resource pool. It was probably a long time ago. It wasn't recently, and I had no clue about this feature. I was just checking things out. I was so excited. I was thinking I'm going to enhance something. And I set up the resource pool, for 10%, max memory %10, because I was like, why should I give it more? Let me start with 10. I started with 10%, and then I expected the queries to stop, especially the ones that use memory-optimized TempDB. I expected those queries to stop when they reached the max 10%. And I look at them, they are just flying using 80, 90%. I'm just staring at them. What the heck? Did I just not mention 10%? Then I realized you have to bind that resource pool to TempDB, because I've not done that earlier. So I didn't even recognize that. Because I think the resource pools that we usually work on, there's not a lot of binding. But with this TempDB, memory-optimized TempDB, you have to bind that resource pool. So that was a good learning, but it did take a lot of time. I wasn't done like in a few minutes because I didn't read the documentation properly. Hey. All right. So I went ahead and did the binding for the resource pool to TempDB. And now I'm so excited to watch because things are going to work. Yes. So I look at it and yes. So when it reaches the 10%, the query stopped. I was so excited. Okay, I got things to be working. All right. And the next moment, I'm not even done with my excitement. The next second, the server is restarting. I can't even connect to the server anymore. I'm like, oh my goodness. I exactly felt like this gentleman in the picture here. I thought I was fixing stuff and enhancing stuff, and now I crashed the server. All right. So, and then I go back and check the logs. Well, in the meanwhile, I just left my desk. Well, it was a test server. So I'm like, I left my desk. I'm like, oh my God. And then I went and got a coffee and then back to my desk. I checked the logs and everything. And that's when I realized, all right, I set the max memory percentage way too low. That's 10%. Because I know you're all super smart. And even though you're all super smart, you still have to read the documentation. Well, that's what I tell myself. Well, not the super smart part, but that I have to read the documentation. In the documentation, it does say you have to mention a higher number for max memory percentage. All right. So that's why I said in the beginning, set that value to, maybe 50, 60, or 70, whatever works for you. You really have to go test on your test servers and crash them, whatever is allowed. Just go do it on your lower environments and see how things work. But what I will tell you is do a higher value, more than 50 or 70 or whatever works for you. Don't do 5, 10, 20 like how I did. Well, if you do, it's going to crash your server. All right, so that's the warning Microsoft has mentioned in the documentation, that you have to set a higher value for max memory % so you don't blow up your server. All right, though this does apply to SQL Server 22 version as well, I have not seen any restarts on 22 version. Well, I really didn't try with 5 or 10 lower numbers, but with the numbers that I have more than 50, I don't see any restarts in SQL 22 version. Any questions about this resource governor resource pool thing?
Yes, and now that you've asked, I'm sure that they were just going to come piling in. So locks and latches exist for good reason. How are in-memory structures protected?
So this in-memory structure thing, That's why, there is this, it's not in the, buffer pool or in the structures where you still need locks. This lives in a separate part in memory where no locks are needed. That's how it is designed.
Okay. Can it hurt performance if the metadata contention isn't that bad?
If metadata contention is really not impacting you, or if you're not being, pinged by your application teams, hey, something is going on, can you check? If you don't get any of that stuff and there's no complaints, you can ignore the metadata contention. It's not going to impact that much. But if it comes to the point like, oh, so people are complaining, things are bad, then yes, you have to worry about it.
Okay, so this one has a statement and then it follows up with a clarifying question. If the feature is disabled, the system objects are on TempDB drive, then I would expect that page IO latch wait types. If contention exists, can you please clarify since page latch addresses objects in memory?
Again, this is all about page latch and it's not about page IO latch. And you will see page latches when the system objects are in the drive or in the buffer pool where the pages reside. This is in a separate part in memory where there are no locks, so you will not see contention. Well, the questions are in different format, but the answer is the same.
Okay, and let's see. Do you have to use resource governor?
You don't have to. If you can, that's why you have to test it out. It's not a must to use the resource governor, but I just put that in place because I don't want these queries that are using memory-optimized TempDB to use 90 or 100% of the memory and then, other queries not getting enough memory, but it's not a must.
Okay, and so this one I suspect is about max memory percentage. What if it's a dedicated SQL server? Can we increase to 80 or 90%?
Oh, for the resource governor, of course, yes. You can increase to 80, 90, whatever works for you. Any higher value is good. But again, test it before you do it on production.
And so does the resource governor control just usage related to in-memory system objects?
So what the resource governor controls is how much memory the incoming process can use. It has nothing to do with if the system object is, drive, memory, none of that stuff. Resource governor will just limit the memory usage for the process that's coming in. If it's using more than, for example, 10 gig, if we set the limit to 10 gig, and if it uses more than 10 gig, then it will stop that process. That's what resource governor is for. All right.
Give me 1 second. Let's see. So with this memory optimized enabled, we still need to have 8 TempDB files for more performance enhancements, or is it just just having memory optimized enabled enough?
Okay, so like I showed in the flow chart, the data files part, the issue with the data files is different from this metadata contention. Let me go back to this flow chart here again. So to answer that question, let me switch this again here. Let me do this. So if you see the question that you are asking is 8 data files enough, or whatever that is enough? On 22, you don't have to add anything. The engine gives you enough number of files and you don't have to add anything at all. That data file contention part is resolved. But when it comes to this metadata contention, data files has nothing to do with it, irrespective of memory optimized TempDB. Okay, this memory optimized TempDB is a completely separate feature that addresses a different type of contention. Don't mix data files contention with this memory optimized TempDB. Those two are completely two different parts. What we are talking right now is just about this memory optimized TempDB that will address the contention on system objects. Whatever is with the data files, that will not be resolved by this memory optimized TempDB. That is different, this is different. All right. And there's
so let me try to ask one from Slack, but this is from earlier. As I recall, in-memory doesn't use latching. What wait types might show up if there are still issues with the write speed to TempDB metadata tables?
Can you, because I can't see the question at the same time.
I know there's a lot packed into that one. In memory doesn't use latching. What wait types might show up if there are still issues with the write speed to TempDB metadata tables?
Okay, so yes, in memory doesn't use latching. So because they don't use latching, it's so you won't see any other wait types when those system objects are in memory. You won't see any other wait types there. It's free from waits because there are no locks.
Okay, no, that's a great answer. Okay.
I mean, when I see the question, it's even easier for me to go back to the question and, you know.
I will drop it in where you can see it, and possibly
Okay.
it could be
That
shared
helps.
later. It's from Slack. It's from Slack. You could go find it in Slack,
Okay.
but I'll save the question so you can go in later.
Okay.
If I understand correctly, memory usage only goes up and never down. If that's true, is the only way to reset memory usage a restart?
Oh, that's a good question, and we do have answers coming up for that in the next slides.
So stay tuned. Okay, so I will let you go ahead and get back to your presentation, and we will get to stuff
right.
next.
Thank you. So where were we? We did the resource governor. We did this. Okay. This is another interesting stuff. Let me switch this thing again. All right. So now that we discussed about the resource governor or the resource pool, all right, don't get confused between resource governor and resource pool. Resource governor is like the title, and the resource pool is what you create to govern those resources. All right. So both actually mean the same. You just create one or many resource pools, how many ever you want. So going back to this topic. For memory-optimized TempDB, this is to limit the memory usage, and this applies to versions above 2019, well, 2019 and higher versions. In SQL Server 2025 version, you must have heard of the enhancement for TempDB to use the resource governor, and in this place, it is only to limit the data file usage. So in case you're wondering, oh, what is this enhancement in 25? Is this related to this? And that's why I brought this up. For memory-optimized TempDB, you can use the resource pool to limit the memory usage. In 2025, this enhancement is to limit the TempDB data file usage. So these two are separate things. Even though they are using resource pool, what they are trying to limit is one is for memory usage. The 2025 enhancement is for TempDB data file usage. All right. And in 2025, well, that would be a separate session. This will work regardless of you have this feature enabled or disabled, and it's only on 25. You don't have this data file limiting thing in any older versions. All right. Oh my God, memory release. So when we actually worked on this feature, we couldn't really understand how this release part worked, and that did hurt our brains, just like in this picture. We really had a hard time to understand, oh my God, what is this memory consumption? How is the release taking place? We had so many incidents where the server was restarted and we thought it was a bug, but it's not, it's a feature. All right. So once when we understood how this release works, let me put it aside, how this release works, this is exactly how we felt. Oh my God, this is how the memory release works. No more server restarts. All right. Okay, so when you see XTP memory, you know that it's labeled for this feature. And this XTP memory can grow without limits, and it can blow up the server. So how does it grow without limit? What's the issue behind this? Well, after I explain, you will see that's not the issue, that's the design. All right, let's go ahead. Imagine you have a single lane road, you have multiple cars with a red light, and there is a red car there where the driver is sleeping. The reason behind me mentioning that the driver is sleeping, you will understand that in a few seconds when I relate that to the transactions. All right. So now there is a green light, and the first 3 cars get to move. because there's nothing stopping them. But if you see the fourth car, the red car, is actually, the driver is actually sleeping. So because of that, none of the other cars can move, right? So they're all just stuck there. Even though their cars are in good condition and the drivers are good, they still cannot move because the car in front of them is stuck. Now let's take this a little bit ahead. Let's call them transactions, T1, T2, T3, and so on. Assume all these black cars are all committed transactions, and this red car is a sleeping transaction. And that's the reason I said the driver is sleeping, so I can relate that to the sleeping transaction, which we use in our SQL Server. All right, you have the red light, and now you have the green light. The first three transactions, they are good to move because there's nothing stopping them, right? Just like how I explained. But now that the red car driver is sleeping, or that the T4 transaction is sleeping, none of the other cars can move, or none of the other transactions can move. Everything else behind it will be stuck. So now let's take a look at these committed transactions here. Let me just minimize this real quick. All right, so you have these transactions in line here. Like the first three transactions are committed, each consuming a couple gig. And then you have a sleeping transaction, which is similar to the red car. And then you have some more transactions there, again, consuming a couple gig each, and they're all committed, all right? When the cleanup task runs, the first three transactions can get easily cleaned up because nothing is, stopping or blocking them. They can just clean up and release that memory. This 2 plus 2 plus 3, 7 gig of memory can be released. Good. But now, again, when the cleanup task runs, these transactions from transaction 4 cannot be cleaned up. It is because there is a sleeping transaction hanging out there. Just like the cars that I showed you, if there is a transaction in the front that is sleeping, not committed, it will not let other committed transactions to clean up either. Even though you have committed transactions here, 5, 6, 7, 8, they still can't get cleaned up because your earlier transaction 4 is still hanging out there. All right. So if you see this first 7 gig is cleaned up, that's good. That's expected. This one here, 2 plus 2 plus 3, this 10 gig is held up. This memory is held up and it cannot be cleaned up until this sleeping transaction is addressed. This is how this memory release works. Now, if you see on a production server, you will have multiple transactions coming in constantly. They are not waiting for anything. They are coming in. Imagine it consumed 20 gig, and then you have 70 more transactions coming in, consuming a lot more, and then so many other transactions coming in constantly. What happens? Until that transaction 4 sleeping transaction is addressed, none of these other transactions' memory can be released. If you see, after a few hours, you will see all that 100 gig or whatever your server memory is, all of that will be consumed, and that will blow up the server. All right, so this is the design of memory release for this feature. It's very important, if you want to enable this feature, you understand how this memory release works. Anything before that sleeping transaction, they will all be cleaned up. The moment you have an open transaction out there lingering, anything after that will not be cleaned up. All that memory will be held up. So there's no memory release, and it will cause a restart of the service. So the point here is, it is not consuming all the memory, or one query is not using up all the memory, because that's what we were confused with. Like, what is that query that's taken up all this memory? No, it's not consuming. It's just that all that transactions memory, it's not able to release because it's not able to run that cleanup task because of open sleeping transactions hanging out there. So that's the important piece that you have to understand. Because of an open sleeping transaction, if it's an earlier transaction in the front, it will not let anything else clean up. So managing those open transactions are important, and that's the one that will help release memory. And talking about this, I want to mention, we discussed about resource pool, right? So resource pool is only to limit the memory usage. It will not help in releasing memory. So just get that clarification. Resource pool is only to limit the memory usage or limit the resources. That will not help in any way in releasing the memory. In releasing the memory, you have to take effort in finding out if there are any open sleeping transactions that's causing the memory to hold up. All right. So the key point here is, if memory is not released, your SQL Server is going to restart. So server, why you crashed so much? I'll tell you, we have had so many incidents where we had our SQL Server restart because of that memory buildup. We did not know what was causing, this issue. The thing is, we didn't realize that it was a buildup of memory. So that's the point there. We didn't realize that the release was holding up. We just thought maybe some query is doing something, or so many things like that. So it was just way too hard for us to find out what the issue was or what the design of this memory release was. Now, looking at hindsight, you'll be like, oh, that's it. It was because of an open sleeping transaction. But at that point, when we were actually working, it was like, oh my God, there's something wrong. What is this? So that's this feature is all about, especially when it comes to memory release. You have to focus on those open sleeping transactions to get rid of them. Otherwise, we are going to be like that, wondering why the server is crashing. So the key here is check or manage open sleeping transactions on your server. Any questions?
Let me pull these up for you. So one from earlier, why do I need to set the resource governor when the 12 system tables are so small?
Yes, the 12 system tables are small, but when the processes are coming in, it will start utilizing that XTP memory, and the memory will keep building up. It will keep using. So when you don't want those processes to be using 80% of your memory or more than 90%, then you have to use resource governor. Resource governor is not for the system tables, it's for the processes that are coming in, which is requesting for all that memory.
Okay. So this one's asking for clarity. The resource governor stops any process that attempts to use anything above the threshold that you've set. Does it throttle the memory used by the process, or does it force it to wait?
So yes, the resource governor stops the process, and it does give insufficient memory errors or out of memory errors when the processes run out of that requested memory, which I will show you in the demo.
Okay, and then a callback to earlier, I had to ask them for clarity on their question, so they provided that. So when you bound the resource pool at that 10% threshold and crashed the system due to memory pressure, was this due to SQL system use of TempDB?
So this was because, yes, I just gave it 10% and that crashed the SQL Server, because what I have seen is when these processes, when they don't get the enough memory that they request, yes, they fail with insufficient memory errors or something like that. But if you set it way too low, probably it's not even getting that a few megabytes or something, then it's just crashing the SQL Server. And I don't know why. The only thing that I've seen is when it is a low number, it does cause a restart. For a higher number, it doesn't do it. And I'm not sure of the exact reason. That has to be something about memory. And that's why Microsoft put out that warning in their document. And I don't see an explanation why. It just says, set it to a higher number. That way you don't have to face those server crashes.
Are there any alerts for open transactions when memory-optimized option is enabled? Does DBCC OpenTran work for this?
Yes, there are alerts, and I just have it in a couple slides down there.
Okay, perfect.
I'll be showing
Okay.
that.
How can I check whether a specific open transaction requires, I guess is required to be on
Oh,
for
requires
those
those in-memory
in-memory
system
systems?
tables?
Yes.
Yeah. So what you can do is, the moment you have create temp table or alter temp table or any DDL of temporary objects in your query, that's when you know it's going to access those in system, system objects or those system tables in memory.
Okay. And then, so about what you just recently showed, why is the transaction not releasing memory? Is it because of memory-optimized objects in memory?
So why is a transaction not releasing memory? The moment a transaction is committed, it will release memory. But if the earlier LSNs are still there, it cannot release the memory. And that's how the design is. Just like how you would have things on your transaction log, or just like how TempDB's version store works. If there's anything in front of it, it won't release the, the data file space or the log file space. It cannot release if there's any transaction in front of it. So if you compare, version store with this memory optimized, in version store, it will be the storage space that it won't release if there is any open transaction out there. Same thing with memory optimized TempDB. If there's any open transaction, it will not release the memory. That's the design.
Right. So in this, I think I'm going to give you a 10-minute warning because I think that's where we are
we
right
just have 10
now.
more minutes. All right, then I'll
Apparently, yeah.
Oh, okay. All right.
So
then I'll
Mark or Anthony or somebody correct me, but it's till 30 minutes after, correct?
Correct. But this is the last session,
Perfect.
so there's no problem with overrunning if you have to.
So
no
none
problem
of
with
us have
overrunning.
anywhere to go. You're good. Yeah.
Okay, that's good. You know what? I'll do the demos and then I'll come back to the questions. Thank you. All right, so where are we? Let me minimize the screen here so I know what's coming. Okay, proactive monitoring. So now that you know you have to manage those open sleeping transactions, you don't have to just go into your server and see, oh, is there any open transaction out there that might be causing the, that might be holding up the release? So set up the proactive monitoring so you don't have to go randomly and check on your server. So what we have done is set up a SQL agent job with a couple of conditions. Alert me when this XTP memory goes beyond 10% of the maximum server memory. Imagine your server memory is 100 gig, and if your XTP memory is more than 10 gig, then it will let me know. Not just that, along with that, if there are any open sleeping transactions that are just lingering for more than 5 hours. So these are the two conditions that I have. Whenever any process or transaction that satisfies these two conditions, then that process will log the session details to a table and send me a notification. What I do is then I go check the server. Oh, so there's something going on. Let me see what that is. Usually that open sleeping transaction just hanging out there, causing the memory to not release. The moment I terminate that session, then in a few minutes I can see all that memory will be released. So before you terminate that session, see what those sessions are and see if they are repeat offenders. You will see a pattern like, oh, it's always this session from this application doing this. Maybe there's something going on. You will have to reach out to the team, talk to them, see what's going on, why this ends up being a sleeping transaction once in a while and causes issues. All right. So the goal here is to release that memory. All right. So you can use this feature very efficiently. And I have this GitHub link here for the script where you have the SQL agent job and these conditions and logging to the table, all this code here in that script. And also that script is part of that GitHub link that Andrew has on 8KB's website. All right. There are some of the limitations. Column store clustered index, if they're on temp tables, it won't work. But I don't know if anyone really has column store clustered indexes on their temp tables. I've never had them, and I don't know if anyone uses them. I'll be very happy to know if any of you are using it. So in the same transaction, you cannot have memory-optimized TempDB query and memory-optimized user table query. in the same transaction, that will not work, that will fail. And I will show that to you in the demo. And the other limitation is not exactly a limitation, but it's just you have to plan around it, because when you enable this feature or when you have to set up the resource pool for this feature, you have to restart the SQL service. All right. Recap. This feature will address all the page latch waits on system objects. That will help reduce the metadata contention. This will not help with data files or anything. It's just about system objects in memory. And once you enable this feature, you will not see any more page latches. So that will give you better performance. And this is only for DDL operation on temporary objects. And you can see that the XTP memory keeps growing, and understanding this memory release is very important because you have to manage those open sleeping transactions. You can set up that, that monitoring script that I mentioned. You can set that up and see what's going on, and that will let you know. That way you don't have to, be worried about server restarts or something. All right, let's go ahead with the demo. All right, here we are. So I'm going to show you the version, CPU count. We are on 20. Okay, I should be on 22. Looks like I reopened it and then that changed it. Just give me a second. So we are on, let me run this. Okay, we are on 22, 14 processors, and I have around 31 gig. And this feature, TempDB metadata memory optimized, is 0, which means it is disabled. I have not enabled it yet. And now what I'm going to do is create two store procedures. One will have the temp table and the other one will have the table variable. Now that the feature is disabled, that's the default one. I'm going to run these two store procedures and see what the execution time is and see if there is any contention. What I will do next is enable the feature, run the same workload again, and see if the execution time reduced and also if the contention reduced. All right, so this is the temp table. Sorry, this is the store procedure with the temp table, just a simple temp table with inserting 10 records into it. Let me create this. And then this is another store procedure with table variable, same concept, but instead of the temp table, I'm having a store procedure here. All right. Now that I have this, what I'm going to do is stress test the SQL Server now. I'll be using OStress utility. It is a free Microsoft command line tool to troubleshoot the SQL Server. And before I go ahead with the stress testing, let me show you this contention script. This is again from this Microsoft website here. What I'm doing here is querying these DMVs, exec request will display the active request, and then SQL text will show you the text, FN page address cracker, and DMDB page info. These two are new functions in 2019 that will give you a lot of information about page related waits. And I'm filtering this by page latch because in this session, we are only interested in page latch. If I run this now, we should not see anything because I don't have anything running yet. All right, now what I'm going to do is run this OStress utility on this server name, execute this procedure, run it on 50 parallel connections and 1,000 times each. So let me go ahead and run this stored procedure here. And it's executing, and looks like I am in the wrong server. So let me do this. And if I check the contention now, I'm on 22, and that's where I'm running the stored procedure. See this page latch wait type on TempDB database ID 2 and on system objects. So this is called metadata contention. If you see these three things, then you know it is metadata contention. And this is the place where you have to enable this memory optimized feature. All right, so let me see. This will take a few more seconds to finish up. And what I'm going to do is, after this is done, well, this is done. Let's note down the time, close to 35 seconds. I'm going to write this down here, 35 seconds. So after I enable the feature, I know how long it took. All right. Now what I'm going to do is, the feature is still disabled. I'm going to run the stored procedure with table variable. The one we just ran was the stored procedure with temp table. Now I'm going to run the stored procedure with table variable and see how contention is. Let me run this. Okay, I still have contention for table variables as well. Page latch on TempDB database ID 2, and this is on system objects. So again, a perfect use case for to enable this feature. All right, let's go check out how long this took. Okay, this was faster, 15 seconds. Again, this demo is not a comparison between if you have to use temp tables or table variables. That's not the discussion here. This is only about before the feature and after the feature, how the contention or the the runtime is. All right. So we have this two executions here. One for stored procedure with temp table that took 35 seconds, and this took 15 seconds. Now what I'm going to do is go ahead and enable the feature and run the same workload again. So if you check this now, it's disabled because that's how it comes by default. I'm going to go ahead and enable it. Alter server configuration, enable this. For this to take effect, I have to restart the SQL service. So let me go ahead and restart the SQL service. I'm just doing it from here because this is my demo machine. Please, when you do it from the configuration manager or the cluster manager, whatever you have. These things are going on to my other monitor, so I'm just pushing them here. All right. Now that this is restarted, I also want to show you the logs here. This is interesting. You will see, let me maximize this. You should see something like TempDB started with memory-optimized metadata. Let's see where it is. I should be able to find it here. I don't know, maybe I can't find it today, but it should be somewhere here. All right, let me go back to my management studio. So if I check this now, this has 1. 1 means that is enabled. All right, earlier we had 0. Now that we ran the server configuration node and restarted the SQL service, you can see that it is enabled now. All right, let's see what system objects have been moved. Here, the expectation is we should see 12 system objects. All right, you see 12 system objects, this, blah, 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 all those system objects here. And the amount of memory this consumed, 61 meg. So initially, when you enable this feature, that's what you see, less than 100 meg, 60 or 80. That's what I've usually seen. But as the process keep coming in, it will keep building up. All right. So now what I want to do is, now that the feature is enabled, let me go ahead and run that same workload again. Here we go. The feature is enabled. So I'm going to run that exact same workload that I ran before. It's running. Let's go check contention. I don't see anything. See, we don't see any contention at all. So that's good. Let's see. It will finish in a few seconds, but it will definitely be lesser than the 35 seconds what we saw earlier. All right. It ran only for 15 seconds. Wow. Okay. So let me note that down here, 15. And the other one is populate table variable. So what I ran now is the stored procedure with temp table. I'm going to run this stored procedure with table variable. It's running. Let's check for contention. Again, no contention, right? Because we enabled that feature, it got rid of all those logs. That's the reason you're not seeing contention here. So this one, it should be done like in a couple seconds now. All right, 16 seconds. What did we have last time? 15 and 16. So it's almost the same, all right? So what do we see here? Before the feature, the stored procedure with temp tables took 35 seconds, but after we enabled the feature, it took just 15 seconds, less than half of the time. So you see the contention is reduced. There are no logs, and that's the reason the stored procedure is able to run faster, all right? And with the table variables, you don't see any difference at all. I've tested this like a million times. I've never seen a difference for stored procedures that run with table variables with the feature or without the feature. The execution time is the same, but there is a difference in the number of page latches. Without the feature, it does have page latches. After you enable the feature, you don't have any page latches at all. That's a difference you see with the table variables. All right. So the next one is, let's see how cleanup takes place. So let's see how much memory is occupied right now. Earlier we had 60 meg, now it is close to 269 because we ran all those stored procedures that had create temp tables in them. That's why it started going up. And what do we want to do now? Let's see how to clean up this memory. So this stored procedure here, syssp xtp, extreme transaction processing, force garbage collection, which is nothing but a cleanup process. So you run this for TempDB once, and then you run this just, plain, which will release the memory for memory structures. And in 2019 version, you have to run this twice. And I don't know why. That's how it's mentioned in the documentation. It's just for 2019, you have to run it twice. But for 22 version, you can just run it once. But because I'm so used to running it twice, I still have that same copy of my code. All right, now that we know we have 269 meg occupied, let's go and run this cleanup task. Now that it is completed, now let's check if it cleaned up. All right, see, from 269, it came down to 57. That's good. This happens on the best days of your life. So you have transactions committed, cleanup task runs, the memory is all cleaned up and released, which is good. But there are days when the other things happen too, which is nothing but, I'll show you right here. So if you check the memory, how much did we have? 57. That's right. What I'm going to do now is, I think I have to get the other script here. Okay, it's here now. So what I'm going to do now is, we do have 57 meg of memory occupied. I will run this explicit open transaction in a window, and in the other window I'm going to go ahead and run some workloads. So what you will see is, whatever workloads I ran, all that memory will not be released because there is this open transaction hanging out there. All right, now let me go ahead, and to mimic production, what I want to do is just run a bunch of stored procedures like how it might run in the production server. All right, so the concept here is, what I'm trying to explain here, I ran an open transaction on a separate window, and then on the other window, I'm running these, good committed transactions. I mean, transactions that will be committed. So I'm running these. What you will see is, even if you run the cleanup will not take place because of that open transaction in the other window. That's what I wanted to show. So this finished. Where is this? So this finished the workload that we ran. Now I want to see how much memory is occupied. We had 57 earlier. Let me see how much is occupied right now. 321. Yes, because we ran a bunch of stored procedure executions now, right? Now let me go try to clean up. This will say command completed successfully, but if you go check how much memory is still there, it will still be in that 300 meg. It did not go down to 50 or 60 like we saw earlier. Now I'll go and run this again for you. Cleanup task. This will not clean up the memory. Check here again. See, it's still at 300. The reason is, there is this open transaction out there in the other window that is either still not committed or not rolled back. All right. So the takeaway here that you have to understand is that open sleeping transaction, which will not let the memory release. Now let's use this query to check if there are any open sleeping transactions. This will give me this session ID 62 begin tran create table, this table that we just ran on that other window. So this is giving me this, that it is hanging out there for 2 minutes. All right, so let's go kill this SPID. Kill 62. I mean, this is my demo machine, so I'm killing it. If you're doing this on your production server, just don't go ahead and kill it. See what process it is. If it belongs to any application team, or if it's anything that's related to, the database team, just, try to take a look and see what it is before you actually kill it. So I'm going to kill this. This will get rid of that open transaction. So let's verify that. We don't have any open transactions now. That's good. So now when you run this cleanup task, it should be able to get rid of that 300 meg memory. The memory release would have happened now. And the expectation now is you will see something in 50 meg, which is 59. See that it was in 300 earlier. Now that you got rid of the open transaction and then did the cleanup, the memory went down from 300 to 50. All right, so that's the concept here. If there are any open sleeping transactions on your server, memory release will not take place. So do manage these open transactions. All right. And let's take a look at the other one here, resource pool. This is interesting. So resource pool, this will be here under management. You see the resource governor. This is where you will see the resource pool. And to enable this, you can actually run this auto resource reconfigure. And I'm going to create a resource pool here, TempDB R pool with CPU and memory percentage. But in this demo, I'm interested in this max memory percentage. And intentionally, I have set it to 2 only for demo purposes. Please don't do this on your production servers or something. Only for demo, that way I can make the queries error out. I can show you how the errors look like. That's why I set it to 2. All right. So here's where you will be setting to, 50, 60, 70, whatever you want that number to be. So I'm setting this max memory percentage. Let me create this. I already created it, so I'm just altering it here for you. And for this to take effect, run the reconfigure statement. Now that you've created the resource pool, remember to bind it to TempDB. This is how you bind it. Set it on and then attach the resource pool here. All right. So let me go ahead and run this. And for this to take effect, again, you have to restart the SQL service. All right. So this one must be here. Let me bring this window, and then this is again here. I'll bring this window here. All right. So what are we doing now? We enabled the resource governor, set up a resource pool, and set that maximum memory percentage, and we are binding that to this memory-optimized TempDB. And we restarted the SQL service for it to take effect. Now, if you check the binding, you will see that TempDB is bound to this resource pool here, TempDB R pool, and we set the maximum memory percentage to 2. So we see that it is all good. All right, now let's also check how much memory is actually occupied now. It's 53 because we didn't run any processes. What I'm going to do now is, again, just explicitly, I want to run this open transaction only for the reason that memory will not be cleaned up, so I can exceed this 2% and show you the errors. All right, so let me just run some transactions, and then I want to run this workload. That way the memory builds up. It keeps using, and you will see how it errors out when it is not getting that enough memory from resource pool. All right, let me go here and run this. Now that we have set the maximum memory percentage to 2, now this execution should error out. In a few seconds, let's go ahead and see that. You will see something like insufficient memory errors. All right, okay, there we go. Let me Control C this, so I want to stop it. All right. If you see this, you see how it is. There is insufficient memory in the resource pool to run this operation on memory-optimized tables. So that's the error you will get when the processes do not get the memory they need, because we have restricted the memory usage for those processes by setting max memory percentage. In our case, I set it to extremely low, just for the demo purpose, but when you set it to any higher value, and if it does not get that enough memory, this is how it's going to error out. All right, so that's about the resource pool. And if you want to take away the binding of the resource pool, what you can do is just run this regular configuration code without the resource pool at the end here. That will remove the binding of the resource pool. All right, oh, I still have this running here. Let me do a rollback, because I had that open transaction out there, right? So, okay, so I have removed the binding of the resource pool just for cleanup purposes. And the next thing is column store clustered index. So like I said, I'm not sure if anyone's using column store clustered indexes, but if you do use them, it will not work when you have this feature enabled. So let me show you that. I'm creating a stored procedure with a temp table, and I'm creating a clustered column store index on this temp table. All right, let me run the stored procedure. Creating the stored procedure will not be an issue. but executing the stored procedure, you will see the error here. Let me maximize this. Maybe I can do this. All right. You see this? There is insufficient memory in the resource pool to run this operation. Oh, maybe I didn't clean up. That's not the error you should be seeing. You should be seeing. No, this is not the error you will be seeing. I don't know why this is coming up. You should be actually seeing that this is not compatible with memory-optimized TempDB. Let me just quickly check. Maybe I did not release the memory. Let's see. Okay, this has 200 meg and, or maybe this is still bound. I don't know. I must have done something here, not properly cleaned up, I guess. But let's not worry about it. Just give it a second and then it should be all set. Okay, yeah, this is right. This is the error. Okay, so I did not set up the memory release and that's why it failed out. And this is the error you will be seeing when you have column store clustered indexes. That column store index creation is not supported in TempDB when memory optimized is enabled. All right. So the point here is when you have this feature enabled, you cannot have column store clustered indexes on temp tables. All right. And the last
Haripriya, we're
yes.
15 minutes over time, so I'm going to have to give you a 5-minute warning.
Okay. Okay. All right.
Cheers.
Yeah, that's okay. I know. All right, I'll just wrap this up. Let me put this here. All right, so it's very important you manage this feature efficiently. Set up the cleanup task to run every few minutes or 30 minutes or an hour. And the most important part is notify, set up some notification so you get those things about long open sleeping transactions if they are out there. And if you are still deciding to enable this feature, there are just a couple more things that you have to look at, especially when you have long DDL transactions where you have, about temp tables running for a long time, then this is not the right place where you can do this. You have to always keep your transactions short. And like I said, with column store cluster index on temp tables, again, this feature is not helpful. Otherwise, you can refactor your code, then that way you can enable the feature, all right? And I've usually not seen this feature enabled on OLAP systems because you don't have a lot of metadata contention because there are no concurrent executions of too many stored procedures on OLAP. All right. And before you enable, I really recommend you to cache your temporary objects and avoid dropping the temp tables at the end of the stored procedures. I've talked a lot about it in my previous session on TempDB contention, and you can take a look at it if you're interested. So the summary here is, this feature addresses metadata contention, especially when you have too many stored procedures running concurrently. And this is definitely not an alternate solution for data files. With stored procedures with temp tables, you will see a very huge difference in performance. This is best to be enabled in SQL 22 and versions above that. And again, to understand how the memory consumption or the memory usage works, manage those long open sleeping transactions. Proactive monitoring is extremely important so you get the best out of this feature. And you can always use resource pools to limit the memory usage. And these are some of the resources that you can take a look at. And thank you. Thanks, everyone. And I'm done with the session. Oh, finally.
Congratulations.
Sorry. It ran long.
Well done. That was amazing.
Thank you.
We've had a few, thank you very much, and that was a great session. Ree had to go off and do some of her work, so afraid you had me at the end, and Andrew to give you the hurry up.
No, that's
yes.
okay.
Apologies. No, we've got a bunch of questions as well, so that's why we sort of
sure.
We did see the amount of scripts that you had as well in that last demo. Like,
so we're like, I better stop her. She's going to be doing it for another hour. Yep, I get it. I get it.
You were on last as well, so we were like,
yeah.
If people are still happy watching, it's okay.
Yep. So do we want to go over the questions, or do you want me to answer them later? I mean, I'm open to doing them now, but it's totally up to you.
Yeah, we can 100% do the questions now.
Okay. Oh, that's good. All right. Would I have okay, you know what? I'll share the question here. That way you can also see it along with me. Would I have the memory block problem if I do not configure memory-optimized tables? So this memory release issue, you will not have it if you don't enable this feature. I have not seen the memory release issue if you don't have this feature on. Yes. How the database engine avoids the problem if two global temp tables with the same name is created from two different sessions. No lockout on the same objects. I don't know. I think it would be the same with even if they are on the drive or on the memory. If you create the two temp tables with the same name, probably they take it as with some hexadecimal numbers in it, and they may not have issues. I don't know. I've never tried that out. Maybe that's a good thing. I can try it out later and see how that works. What is the LSN relationship? What do you mean by LSN relationship? Oh, it's because I mentioned about the earlier LSN. LSN log sequence number. It's like, when you have to point out to a transaction, you can do that by that number. If you have an earlier transaction, instead of LSN, you could just say, if you have an earlier transaction out there that is sleeping, it will not let any other transactions clean up. And how do you know that's an earlier transaction? By referring to that number there. That's what I meant. In the demo scripts, you are executing store procedure using ostress. Is that doc available anywhere? Yes, that is actually available in the GitHub link. You can get it from there. What was the tool name again? That was ostress utility. Locks and latches perform a critical function in data integrity. Is there a risk of integrity issues? I don't think there is a risk of integrity. If there had been, I don't think this feature would have come out, is what I'm thinking. From at least what I have tested, I have not seen any data integrity issues. They are all non-durable, whatever you're doing with TempDB, so I've never seen any issues. How often should you run the cleanup task? Well, the cleanup task already runs in the background. You don't have to necessarily run it, but we at Workbase, we do run it only to be on the safer side. You don't have to, but if you want to, you can run it every 30 minutes or every hour. We currently have it every 30 minutes. Should you create a housekeeping job for the cleanup? It's a good idea. You can have a housekeeping job, like I said, every 30 minutes for the cleanup. But if you have an open transaction, you still have to manage that transaction by terminating or rolling back or doing something with that. It's just like an open transaction will not let you clean up the log file. Yes, the similar. It's just a similar concept, but applied in different places. How often is the normal garbage collection happening? I don't know. Actually, I haven't seen that written anywhere. Like if it runs for 5 minutes or 10 minutes, I have not explicitly seen it written anywhere. I have looked for it too, at least like last year. I don't know if anything changed in the last few months, but I've not seen it anywhere. I know it runs in the background. Am I correct in saying that by moving the TempDB into memory, MS SQL has moved the same issue with open transaction TempDB and filling up the disk now creates the same issue with memory? I don't think that is correct. It's just it's by the design that this memory is not being released. I don't think it's because of those system objects consuming the memory. I know this ran long, but I really appreciate being able to see the demos and thought, okay, thank you. So you don't recommend it for 2019? The only reason I don't recommend is because I've seen a few restarts, especially with the resource pool and everything. And also in 2019, that's the first version it was released. So that's why I was just a bit skeptical. But if you do want to enable it, go ahead and test it out. What downsides have you seen using this feature besides crashing this server? Downsides, managing that open transaction and setting up that notification is extremely important. So, according to me, it's not a downside. I had to do a lot of learning, not just me. Like we as a team, we did a lot of research, a lot of learning, whatever I've put it out in the session, that's a lot. And I know Anthony would like to answer this question. Anthony, is there something you would like to mention about this?
No, I accidentally hit the button. I'm sorry.
Oh, okay. All right. Very interactive. Would be happy to attend some more session. Thank you. Excellent. Thank you. All right. Is that all? Oh, I should have hit answer. Like I didn't do that, I guess. But okay. All right. Fine. If you're
That's no worries at all. Okay, thank you so much. We've got some fantastic feedback coming through for your session. Really, really good stuff. Can I grab the screen, please?
Yes, please. Yeah. Thank you. Okay, let me hit stop share here.